So thank you for coming. I'm Yifan. I'm a currently student at Northeastern. Today I'm going to talk about asynchronous programming in Scala. So let's get started. A quick addenda of today's talk. We're first going to introduce synchronous and async, briefly mention, and then we're going to dive into features and promise in Scala. We're going to talk about Monix. We're going to compare them. And then finally, we're going to get to talk about some of the best practices in debugging asynchronous code. So when we talk about concurrency, there are several words that we often mention, right? We mention synchronous, async, single-threaded, and multi-threading. So what are the differences? They're confusing. So, well, okay. Here's a spoilers alert. I don't know if any of you is hungry, but I am. So I'm going to use food as an example. Well, so in asynchronous single-threaded environment, I am the only thread that's cooking my breakfast, right? So I'm going to cook the omelet, wait till it finishes, and then I'm going to move on to making the toast. And I have to wait till it finishes to move on making the coffee. But in synchronous multi-threaded environment, what I can do is I can have two wonderful friends coming over, and I can cook the omelet, wait till it finishes. At the same time, my wonderful friend 1 will come help me to cook the toast. When it finishes, my wonderful friend 3 will come and help me prepare the coffee. So in asynchronous single-threaded environment, here's what's going to happen. Myself cooking the breakfast, but when I prepare the egg, I will set a timer, say that I'm going to come back when this finishes. And then I will move on to making the toast, and then I set a timer. Then I move on to brewing the coffee, set a timer. Now I've got all the time in the world. I'm going to sit down and read a newspaper. But when the result finishes, we collect the result, we eat breakfast. Remember that when you are reading the newspaper, you're not necessarily waiting for the task to finish. You're actually executing another task. In asynchronous multi-threaded environment, what's going to happen is that you prepare the egg, you set a timer, and your wonderful friend 1 will at the same time prepare the toast, set a timer, and your wonderful friend 2 will brew the coffee, set a timer. Now you guys got all the time in the world. You can play board games together. And then you collect the result at the end. So asynchronous sounds wonderful. How do we achieve that in Scala? In Scala.concurrent, we have this wonderful library, two wonderful libraries, future and promise. What is a future? A future, you can think of it as a container that contains a value that may be completed at some point in the future. Remember that future is immutable. That means that you're not allowed to modify the future after you've created it. So in future, we have several words that we usually mention. If the computation is completed, we say that the future, if the computation is incompleted, then we say that the future has not yet completed. If the computation is completed, it could either has a value or a failure. So we can say that future is completed with a value, so that you completed with a success. If not, if we got an exception, we say that it's completed with a failure. So there's some very interesting functions that you can use in future. What you can do to register callbacks is that you can use onComplete to register a callback. What you do is that you say you're going to shuffle some data over the network, and you don't really want to wait for this, right? So what you do is you wrap this thing in a future, and you use onComplete to register callback. You say that if my future completed with a success, I'm going to use whatever I got and to process it, probably some data, process the data. And then if I got a failure, if it's non-fatal, I'm going to log it or print it, do whatever you need. And then I don't have to wait for the future to finish before moving on to execute another task. Remember that using onComplete, you can actually register several callbacks on one future. So that means I can call onComplete on the same future several times. But remember, there's no guarantee that your callbacks will be executed in the same order that you register them. That means if I call this several times, it could be executed in a different order compared to the order I wrote them down. So if you take a look, there's an execution contact. This basically is a wrapper around the fork join pool that helps you to manage your threads. So there's another interesting callback. It's called and then. What you can do with it is you create a future, and you can actually chain your callbacks together. So instead of calling one, like onComplete, you can call it on every future, but this one you can actually chain all of them together. And this one allows you to execute the callbacks in a very specific order. So it will execute the first case and then execute those two cases. And there's a interesting example for throwing an exception. Let's say that we create a feature, we got some successful results, but when we're registering callbacks, the first clause we got an exception. In and then, it doesn't actually propagate your exceptions. So if there's an exception in the first clause, my second and then will actually use the successful result from my original future. So in this case, I will actually get this successful value back. So remember this when you're using and then. So for transformations in future, we can use this very common function called transform. What you do is you pass in two higher order functions, one dealing with what happens when you get a successful result. The other one is when you got a throwable. So one example will be, let's say you're shuffling data over the network again. You can say, if my future is completed with a success, I'm going to process the data. If there's a throwable, I'm going to do something else and return it. And if you notice, in Scala 2.12, there's another transform offered. So when you look at it, when I first look at it, I was like, what's the difference? They're the same. Why are we having the same two transforms in the same library, right? But if you look at it closely, so the difference is that this one allows you to have, it's more flexible, allows you to have more flexibility. The difference is that this one takes a try and returns a try. So for example, if in our future there's an exception got thrown, in the case of a success, we do something with the data, but in the case of a failure, now I can actually wrap my exception. We can hide it, right? We can say that I don't care, just return a success. And this one is actually more generic, but great power comes with great responsibilities. So when you're using this, keep this in mind that it might swallow your exception. Also, another very interesting transformation that specifically deal with exceptions is this recover. So what you can do is, let's say if I'm dealing with if I'm doing horrible math in my future, right? If I say 6 divided by 0, and it's obviously going to throw me an arithmetic exception. What I can do is I can use recover, say that in the case of this exception, don't give me the exception, but give me 0. So it will work fine. But if I say, if I provide the case that doesn't match with the exception, if I say, if there's a no such element exception, which it won't happen because I'm getting arithmetic exception. In this case, recover will actually use the result from the original future. So you will get a future with the arithmetic exception. If my future completed successfully, my recover will actually also use the result of my successful value from the future. There's also another thing that's similar called recover with. Instead of recovering with a value, you recover this with another future. So I can say in the case of the exception, I recover this by using the result of the other future that I just created. One thing to note is that for recover with, it's only evaluated after you get a failure. So if you get a success, it won't even look at the clause, which is different from fallback to. So fallback to gets evaluated whenever you create it. It doesn't care whether you got an exception or not. So for example, I can say if my task 1 failed, I'm going to fall back to task 2. And this will get evaluated regardless of whether task 1 is finished or not. If both future failed, then it's going to use the value from the first future. So let's look at a promise. What is a promise? So you can think of a promise as a writable single assignment container. And if you're confused about the difference between futures and promise, you can think of a pipe. So a promise is the side where you push data in, and then the future is the side where you grab things out. You can use a promise to create a future. You can also use it to complete a future. So one example for using promise that you can use this to complete your future by using complete. So let's look at an example. We create a promise by calling promise, and then we have access to our future by calling p.future. And then it's really nice. It allows you to register some callbacks on the future that you just got. And then you can say, OK, let's complete this promise. I'm ready. So I'm going to complete it with a success. But if I complete it again with a different with a different value, or even with the same value, I will get an exception back because I can only complete the promise once. So in this case, I will get a promise already completed illegal statement exception. And you can also, in promise, you can also use success and failure to complete your promise. You just have to make sure the input matches. Also, this really nice function, you could, if you really don't want an exception, you can use try complete, which pretty much do the same thing, but instead of throwing you an exception, it's going to return you a Boolean telling you whether I've successfully completed the promise or not, right? So in the case of a failure, we're just going to get a false. And now we've been looking at futures and promise for a while. I'm sure you guys are ready for a little quiz. So let's say I'm building a client interface, right? I'm building this for my client, not for myself. And so raise your hand. I'll give you a few seconds to read the code, but raise your hand if you think there's a problem with this code. Okay, John hates my talk. He's going to leave. Okay, raise your hand if you think there's a problem with the code. Okay, a few. All right. Yes, if you know me really well, there's always a problem. So what is the problem? Remember that we're building a client-facing interface, right? I'm actually returning this to my client. So the problem is, let's take a look at what we're doing. We create a promise, and then we're doing something in our future. We're saying that we're working on some very time-consuming tasks, and then when we're done, we're gonna complete the promise. So remember that if you wrap things around in the future, your code doesn't wait for your future to finish before you move on to another one, right? So when I return the promise to my user, the future might not be finished yet. So that means we probably didn't even complete the promise. So if my client tries to complete my promise, then I will get an exception, right? Because you can only complete the promise once. So you're giving away the power by returning a promise. What you really want to do is that you want to return a future so that your client can register callbacks on your promise. But you don't want to return them the promise, right? You want all the power. Well, that's the point, right? And I told you this is a client-facing interface, so be careful. So let's talk about Monix. What's the difference? Well, first of all, what is Monix, right? Monix, you can think of it as an asynchronous event-based program. In Monix, there's a common data type called task, which we'll be focusing on today. You can think of a Monix as a factory of future instances. It creates futures. And because of that, Monix is actually evaluated lazily. So one common example is you can use task. You can think of it as a pretty common, think of it as a very, very similar to future when you're first learning Monix, right? So what you do if you want to do some task concurrently, asynchronously, you want to wrap that in a task. So what's going to happen when I create this task? Well, it's a trick question because nothing will happen. We just said that Monix is evaluated lazily. That means it will only get evaluated when I specify. So when I say data.run async, that's when it gets evaluated. And this will return me the cancelable future. And if you look at right there, it's instead of an execution context, you have to pass in implicit scheduler. A scheduler is a nice wrapper around the execution context. It provides some really nice functionalities, which we'll talk about later. Let's see, next one. Okay, there's a really nice function called run on complete. What you can do is you wrap your task into a task, and then if you call run on complete, it allows you to register callbacks, and it eagerly evaluates your task. So you can specify, in what case do something, do whatever you need to do. But in this case, you don't have to actually call run async because this one is evaluated eagerly. This is very similar to future on complete. So the next one. So if you want to say, what if I just want my task to be evaluated eagerly all the time? Well, you can. In task, you can actually call task.now. So by calling this nice function, it evaluates all the tasks that you created inside eagerly. This is similar to future successful. If you say, well, I want my evaluation to be evaluated lazily, so you can use task.defer. If you wrap your eager evaluation in this will evaluate everything inside lazily, which is similar to task.eval. So in Monix, there is a nice feature that everything is not memoized by default, right? So if you create a task by calling task.eval, the first time if you call run async, it's going to evaluate your task. It's going to do the side effect. And the second time if you call run async, it's going to do the exact same thing because it's not memoized, it's not cached. Which is different from future because future by default, everything's memoized. If you call eval once, it's actually going to memorize it because you're specifying, please memorize my result. So what's going to happen is the first time you call run async, it's going to evaluate the whole thing, and it's going to store the result. It's going to cache it, memorize it, and the second time when you call, it won't actually evaluate it, but it will just return you the result that you memorized. This nice function is called memorize on success. So what it does is it only memorizes the result when you get a valid result back. So let's say we have a task that randomly throw exceptions, right? So the first time I call run async, it throws me exception. I'm not going to memorize it. Second time, again, not memorizing it. And then the third time actually gave me a valid success number. So I'm going to memorize this result. Next time when I call run async again, it will actually yield the same result because it memorized it last time. In Monix, you can actually override the default thread pool. So what you can do is you can call this execute on method. You can create the scheduler by calling scheduler.io, given the name of the new thread pool that you want it to be. You can create a task and then call execute on this task, and it will create a new task overridden the default scheduler. So when you run async, when you let it evaluate your task, this will actually print out and telling us that this is using a thread from the thread pool that you created. And what if I override the thread pool several times? Let's say I'm creating 2 thread pools. I'm calling it twice on the same task. So remember, task is immutable, just like future. So if I call it the second time, it's actually not going to do anything. If I call run async, you can see that it's still using the thread from my first thread pool. Also in Monix, you can actually cancel your future. So what you can do here is using this cancel function. You create a task, you delay the execution, and when you call run async, right here, if you change your idea, you're like, I don't really want my result anymore. So I can call cancel. This won't return you the result, so you will never ever get the result from the task back. And you can call it multiple times on the same task, and you will get the same effect. So we've been looking at future and Monix for a while. Let's compare the difference. Well, the first one, the most obvious one, is that one is eagerly evaluated, the other one is lazily evaluated, right? So future is a value, but task is a function. It's a factory that creates future. So in future, you execute it whenever it's created. But then in Monix, you can actually control when you want it to be executed, to be evaluated. Also in future, since it's evaluated eagerly, you have to pass in the implicit context whenever you create a future. But in Monix, you can actually just need the scheduler whenever you execute it, whenever you call .run async, right? And second of all, memoization. So we talked about that future is memoized by default, but task is not. So future, when you evaluate, it's going to remember the result, but in task, it's evaluated whenever you need it, and it's going to memorize the result. Well, you can actually decide whether you want it to be memoized or not. And this provides referential transparency. That means every time when you call a Monix, if you say that I don't want the result to be memoized, then it will have the same side effect every time you call it. So that's called referential transparency. For error handling, in future, we've looked at a few examples that could possibly swallow our exception, right? But as a developer, you don't really want that to happen because it's hard to debug. But in Monix, the scheduler, the context, the execution context actually has a nice feature called report failure. So it defaults it reports the failure to your system.error. And you can actually override the customized, using some logging tool to override the default error handling. So how do we convert a future to Monix? So in Monix, there's this thing called task.from future. You can put the input as your future, and this will create a task.now. So this will get evaluated eagerly. But if you say, I want my task to be created and I want it to be evaluated lazily, so I can use task.defer, I can wrap the thing in my task.defer, and this will return a lazy future, just like a task. And from Monix to future, well, since we said that Monix is a factory of future, so whenever you call run async on a task, it produces a cancelable future. So you can actually create a future by just calling run async. And now, finally, come to the part of debugging. Well, we all know that debugging asynchronous code is extremely hard, right? Nobody really want to deal with it, but we have to. So let's talk about it. Well, think about, going back to the breakfast example. If I'm having multiple friends in the kitchen trying to cook the breakfast, if we're all trying to work on the same thing, that could easily mess up our breakfast, and that will make the day really horrible. Too many shifts spoils the broth, right? So we don't want that to happen. Well, what should we do? So when we're writing asynchronous code, when you're trying to debug, and when you realize that yourself trying to add more code to fix a problem, then you probably should step back and rethink. What am I doing? Am I really fixing the code, or am I really like adding more code and creating more bugs or hiding the bug, right? So you want to be able to step back and look at your design before you do that. And when we're testing asynchronous code, it's really important to create environments that isolates the chunks of asynchronous code. So you want to put your code in an environment in which you fully understand. You want to make sure that the results that came back is exactly what you expect. And after you've done that and you made sure that it's correct, then you can move on to the next chunk of code. So one example is that we can use await and print. So in await.results, you can use this function called result. And how we do it is, let's say we're cooking the breakfast, and we make the omelet, which will return the future of omelet. We make the toast, returns the future of toast. We make the coffee, which will return the future of coffee, and then we cook the breakfast in parallel. We don't really want to wait, right? So we cook everything in parallel, and then here, when I want to make sure that it actually returned me the result that I expected, what I can do is I can say await.result, and I can say, here's the future that I want to check, and here's how long I'm willing to wait. And this will return you the result, and you can actually print it and see, is this what I really want? And this at most is a duration. It could be a positive number, which represents how long you're willing to wait. It could also be a negative number, which means you're not willing to wait at all. And then it could also be a duration.inf. That means you're willing to wait for forever. So you will get a timeout exception if your future did not get completed before the timeout. Another thing in Scala test is that you can test your future using when ready. So in when ready, you pass your future in as an input argument, and you say in the curly brace, you can say this is the result. Let's say if we're using the breakfast example, right? The R will be a breakfast, and then we're saying this should be something that I expect, and you check. And also using when ready, and you can also overwrite the timeout by specifying how long you want it to be. The default timeout is 150 millisecond, but you can overwrite it how long ever you want. So you will get a test failed exception if the future didn't finish before the timeout. Okay, so there has to be a better way, right? We can't always use print. So I looked online and I found two wonderful tools. Async Debugger, developed by Julian, and Capture was released in 2017 by IntelliJ. And here are some documentation that I put in the slides. You can have it later after the talk. You can read it if you want, but I'm going to briefly cover how it works. So in Async Debugger, how it works is you put a breakpoint at the place where you run your async code. The debugger will substitute the async code with wherever you called the code. and it has a stack that stores the values, the variables, the stack traces as variables and assign them keys in a map. And the map has maximum of 1,000 stacks. And you send messages between processes. You send the keys around so that the other process can later on refer to the map and grab the stack trace. And the senders are the part that calls your async code. The receivers are the code that's been executed. You have to, in IntelliJ, you have to config exactly everything. So you have to tell it what's the class name, what's the method signature, the input, output type. And okay, so so this is really hard, right? So I actually asked people around before putting all this together, and one of the people that I asked is Alex, the expert of Monix, the author. So I said, well, Alex, do you have any suggestions on debugging async code? So here's what Alex said. Well, I'm not sure how to answer you because this is really painful. But I guess you just have to use printlns and breakpoints, just like what you do with normal code, right? And he also said, well, there probably isn't any official ways to do it yet, but we would like to have a solution in the near future. So we all know that debugging async code is hard and painful, and I don't believe what we have right now is the most elegant solution. But as a community, I think we can do better. We can come together, find a solution, and bring it to the world. So on top of that, this concludes my talk. And so far, nobody has thrown anything at me yet. I'm believing I'm doing a decent job then. So, well, thank you for being here and enjoy the rest of the conference. And I will take questions. Yeah.
What are a few scenarios in which actually lazy evaluation of features is helpful?
Yeah, so let's say you're saying you're using Monix, and you think that lazy evaluation will be helpful.
When is it actually helpful?
Oh, when is helpful? Well, there are several cases, right? So for example, one of the things that lazily evaluating a feature provides, like you don't have to pass in the execution context whenever you create the feature. Because sometimes that could be like very cumbersome. You don't want to have to do that every single time you create a feature, right? So Monix provides, so when you create a lazy feature in Monix, a lazy task, you can only, well, you will only be able to, no, you can pass in the scheduler whenever you want, but you will only need it when you execute the code. So in that case, it saves you a lot of trouble. You can actually less code, right? Yeah. Yep. Actually, I think Alex said that in his documents. He said he was inspired. I believe it was .NET or Scala Z. I'm not exactly remembering the lines that he wrote in the documentation, but I can definitely send it to you. That was definitely inspired by some libraries. Yeah. Yeah, and I remember he wrote in his documentation said that Monix is standing on the shoulder of a giant. So. Yeah, I'm happy to send you the doc after. Yeah, any more questions? Yeah, that's a very good question. So when you look at Monix, we did a few slides comparing the difference between Monix and the future, right? So one of the nice things that I like to have is to have my error logged. I don't want my error to get swallowed whenever I have them because debugging async code is already hard. I don't want to make it harder by like not seeing the error or not being able to understand where it happened. So one of the things that Monix provide is you can log your error. It won't. So I think in the documentation, I'm going to quote him again. He said, there's an interesting mental experiment is when there's nobody around, if a tree falls down, will anybody actually be able to hear it? Well, will it actually make a sound, right? So in our future, the execution context is the forest. And it's doing something with itself, and it's like having a lot of threads, and it's managing itself. So as a developer, standing outside the context, we don't really get to always see what's inside, what's happening. So that's your tree. Well, that's your forest. But if a tree falls down, that means if an error gets thrown, will I be able to actually see it? And I don't feel safe if I don't see it because I don't want to have to like debug and trying to find where exactly happened. So Monix helps a lot. So it will actually help me log my errors. And that's something I really want. Yeah. Yeah. Uh-huh. Right. Yeah. Right. Yeah, so Monix provides you the ability to decide when you want your future to be evaluated. But when you're using future, you don't really get to decide. But in Monix, you can decide, okay, I want this to be evaluated right now, so I can use task.now. But let's say I just want to evaluate it after certain task. I can actually say, create the task here, do something, and then I can say run async. That's when it triggers the evaluation. So yes, as a developer, sometimes you probably want to be able to control whenever your future gets evaluated. Oh, 1 second. I just want to point out something that's really quick. I'm glad you mentioned about the in the for comprehension. So there's a nice thing that I thought I wouldn't have time to mention, but it looks like I do. So in here, right? So if why did I write the future outside of the for comprehension? Does anyone know? Yeah, exactly. So if I write it inside, I will have to actually wait for my first future to finish before executing another, right? But if I create it outside, this will actually be executed in parallel. Yeah. So
I think normally confusion starts because people don't see that it's a flat map. But basically, if you do with the
it's
flat
a
map,
sugar
everybody
syntax
understands.
trigger, right? Yeah. How does what work? Sorry. The cancellation, yeah, good question. So cancellation, I'm trying to find the slide. Uh, here. Okay, cancellation. I did ask Alex because when I was reading the documentation, he explained like outside as a user how it works, but then I actually want to know how he implemented it. So basically we have the scheduler as the execution context, right? What it does is it actually manages the thread pool, but also schedules your event. So here, when let's say I'm creating a task and I say that I'll wait a second before I actually evaluate it. So here, when I change my mind, this will actually just cancel the scheduler. So I can't actually kill the process because you will get an exception if you were like forced to kill the process. But this cancels the scheduler, and you won't actually get the result back. So the scheduler won't give you back the result. Yeah.
Possible to kill a task specifically already scheduled. So that's a problem normally in Scala features. If you have a very long running task for 10 seconds, you want to cancel halfway. Is it possible to do that with Monix?
I don't think so. I've read through the documentations. I think you can only cancel. Right. Okay. Anything else? I'm glad you guys are asking questions. That means people paid attention. Yes. Yeah. I will. And on top of that, I'm only showing, because, well, I can't possibly show the whole Monix to everyone within 40 minutes, plus other content, right? This is definitely only the tip of the iceberg. I believe there was a talk earlier about observables in Monix. So you can do a lot of things with Monix, and this is just showing the things that are similar to future. Anything? Yeah. Yeah. Well, depends. So with future, the execution context doesn't provide you a free scheduler, but you can always write your own, right? You can actually use a scheduler. You can actually write your, well, I mean, there's Monix, so you probably don't have to do it, but if you really want to, you can actually write a scheduler that makes your future to be evaluated lazily by like scheduling it instead of executing it. Yeah. But why not? Like, why reinvent the wheel if there's somebody already did it, right? Yeah. Anything else? Okay, we got a .NET expert here. Talk to him. Anything else? Yeah, very good. Yeah. Oh. I will definitely be here until my train is like 1 a.m. So I'll stay here. Yeah. Oh, yes. Okay. Right. Oh, thank you. That's so nice of you. But yeah, talk with me. I'm happy to talk with any one of you. If you have questions, concerns, suggestions, or just anything, come find me. I'll be here for a while. And if you're curious about Scala Bridge, or if you wanna get involved, also come find me. Oh, also I will post the slides. I probably will post it on Twitter. Or what's the best way that people can get it? I think Twitter, right? Oh, okay. Yeah, sure. Okay, yeah, you guys can actually find the documentation that I put in there. A few good ones about, oh, I can't even remember where are my slides. But anyways, I had documentations on debuggers, which are, I guess people are interested in those. So feel free to get it and read it. So thank you so much for being here and asking for so many wonderful questions. You guys are free to go. Woo!